So the next part of this, I'm going to bring one of my colleagues up, Tim Uzar, because he knows a lot more than I do about geothermal. I can answer most basic questions, but he's an expert. He designs the systems. He does manual J's, manual D's. I know what they are. And so I want to bring Tim up to talk about those. And this is his presentation that I slightly edited, so if he has any surprises, then I apologize.
And yeah, this was kind of thrown at me at the last minute, about 10 o'clock last night. So I guess everybody here knows what a geothermal heating and cooling system is. Just to be real basic, it's a heat pump. Most air-to-air heat pumps get a bad rap because you know, in extreme cold, they have a hard time heating a house. Well, that heat pump is sitting outdoors in the ambient temperature. When it's 14 degrees outside, it's quite difficult to find some heat in that environment to basically put into your house. A good analogy that I give is let's just say you have to go out in your yard and dig a hole. If you do it on a 62-degree day, it's not too bad. You can dig that hole pretty efficiently. Your body is able to put off heat as needed when you get hot, and it's able to take in heat if you get cold, which I doubt. So imagine that 62-degree day. You're digging that hole. Now imagine it a 98-degree day. You're not going to work quite as efficiently. Same thing on a 14-degree night. It's cold. You're going to have a hard time working. Well, your heat pump's no different. It's sitting outdoors in that ambient temperature. Now let's take the heat pump and remove it from the outdoors. Let's put it in a controlled environment. That 14-degree day, let's go put it in the swimming pool underwater. All right, even though it's 14 degrees outside, that swimming pool is probably around 50 degrees. That's 40 degrees temperature difference. It's a lot warmer in that water. And if you were outside digging that hole, that in 14 degrees, that 50-degree swimming pool would probably feel warm. The same concept here in Atlanta, the earth temperature is 62 degrees. 62-degree core earth temperature. That's at 20 feet below. Once you get you know, a little close to the surface, you start to have some swings in temperature. Most systems here in Atlanta are drilled well systems because real estate is you know, it's a prime commodity, and nobody wants to give up an acre of land to put in an air conditioning system. So that's okay. You know, they function better when they're deeper in the earth. A lot of people come to me with questions about, you know, well, I think I've got some granite. I think I've got some stone. What do you do then? It's great. We drill right through it. Granite has the highest thermal conductivity of any soil that you could imagine. Just one example is, you know, put your hand on the tablecloth in front of you and feel what happens. Now put your hand on a granite countertop. It feels cold. That's the countertop literally extracting heat from your body. That's what we want. Granite extracts heat very well. It also retains heat very well. We want to use your yard as a battery. Think of it as your heat pump is pretty much putting heat in the summer into your refrigerant, and then takes it out of the refrigerant, instead of with a fan and discharging it to the atmosphere, putting it to water. Well, that water is going to eventually heat up itself, so we circulate that water through the earth. We disperse that heat into the earth. By the end of summer, we've now heated up the yard pretty much. It'll maybe raise 10 to 15 degrees in temperature. That's okay, because fall's coming, now winter. Now we're going to start extracting that heat out of the yard. If you've heard of a high efficiency furnace, 0.96 AFUE. Well, that's 96% efficient. Heat pumps, geothermal heat pumps, are 5 COP, which is technically 500% efficient. For every 1 unit of energy that it pulls from the earth, 1 unit of energy that it takes from the power company, it gets 4 additional units of energy free from the earth through that concept of discharging heat into the earth and then taking it back out in the winter. So if somebody tries to sell you a high efficiency furnace at 0.96 efficiency, geothermal's 5 times that. So it's a great system. Through some of the basics. Here's a picture of a drilling rig. One thing to keep in mind when installing these systems, it's going to make a mess. Just once you get that in your head first, understand there's going to be a mess. You can clean it up. Generally on a retrofit, I always put in some landscaping cost in there, and when we're done, you never know we were there.
But most of the time you drill the wells for new construction at the time when the site's not completed anyway, correct?
Exactly. Yeah. Generally, the good thing about well drilling is it's very flexible about when you can show up. We can show up before you pour the slab. We can show up during framing. We can show up during air conditioning rough. We can show up right before trim. You do need it before you trim the house out because you plan on starting up the unit soon, so you want to have it, the lines in place by that point. So it's a pretty good thing to float on the schedule. You can work it in where maybe not that many people are on site at that time. Generally, you'll do 1 200-foot deep well for every ton of heating and cooling. You can get away, if you go with 400-foot deep wells, you can get away with about 2.75 tons per well because it's a larger pipe, more surface area. It's also a deeper well, so there's more constant temperature of the earth. The pricing's the same. Really, it just comes into space. If you've got a lot of land, just put in some 200-foot wells. You can get about 2 of those done a day. If as this project here at Candler Park, we had about, I'd say 75 square feet. We squeezed 2 400-foot wells in for a 4-ton system.